All right, so we're going to look at some new terminology. Asymptotes. They are lines, usually invisible, in space that a graph gets closer and closer to, but never touches. There are two types of asymptotes. Number one, you have a vertical asymptote, and number two, you have a horizontal asymptote. So, a vertical asymptote is a vertical line which corresponds to zeros of the denominator of a rational function. So that's what we're going to be looking at here. So if you notice, if you look at our dotted line in the four graphs that we have here, these are our vertical asymptotes. And it says here, whenever we create this vertical line, it's x equals to a, and I'm going to show you how to find the vertical asymptote. And it says, as x approaches a, so whatever a is, from either the left or the right side, our f of x will approach positive infinity or our f of x will approach negative infinity. So we're going to look at how to find the asymptotes. Now this is the one we're talking about, vertical asymptotes, right now, and then we're going to get into horizontal asymptotes. So think about horizontal line goes left to right, vertical line or vertical asymptotes go up and down. All right, so let's first find the vertical asymptotes. Let's look at some rules here that we're going to follow to find the vertical asymptotes. So it says here, find the vertical asymptotes, if any, and the value of x corresponding to wholes, if any, of the graph of the rational function. So you may be asking, well, what is a hole or what are wholes? A hole on a graph looks like a hollow circle, an open circle. It represents the fact that the function approaches the point, but is not actually defined on that precise x value. So we're going to do some examples where some questions there isn't a hole there, HOLE, and when there is a hole, HOLE. There are two cases to determine if, when finding the vertical asymptote, is there a hole or not. Case 1. If there is a common factor at both numerator and denominator, there is no hole for the rational function. Case 2, if there is a common factor at both numerator and denominator, there is a hole for the rational function. So basically what this is saying, we want to first see, to determine if there are any holes, we want to see if the numerator and denominator can be factored. If so, then there is a hole if it's factorable. If we cannot factor the numerator and denominator, in which for this question f of x is equal to x over x minus 9, it cannot be factored. So at this point, there are no holes, and we're going to do an example of one. Okay. All right. So how to find the vertical asymptote? Well, what we're going to do is set our denominator equal to 0, and we have x is equal to 9. Now we know that at positive 9, that we know that this will make this function undefined. But what we would do is find x equals to 9. We would graph this vertical line, we'll make it a dotted line. And what this is saying, remember that an asymptote is a line that a curve approaches as it heads towards infinity. It'll never touch the actual graph itself. It'll always get close to the graph, but it will never ever touch. So we can go back to this example here, or the examples that we have here where you have your vertical asymptotes. Yes, it's getting the line that's created here is getting close to the vertical asymptote, but it's not actually touching the vertical asymptote. Okay, so find the vertical asymptote. We did. X is equal to 9. Are there any holes? No, because we were not able to factor the numerator and denominator. Let's do another example. We have here h of x is equal to x plus 3 all over x times x plus 1. Okay, so can we factor the numerator and denominator? No, we cannot. All right, so let's do some things here. Where will it be undefined at? Okay, it will be undefined at, remember we can set each factor equal to 0. So x equals to 0, x plus 1 equals to 0. We will subtract 1. We have x is equal to 1. Therefore, x cannot be 0, nor can it be -1. So it's undefined there. So, and then this is where we would draw our vertical asymptotes. Okay. And when we draw our vertical asymptotes, it's going to be a vertical line. And so our vertical asymptotes will be at x equals to 0, x equals to -1. That's where our asymptotes would be at. And then do we have any holes here? Yes or no? There are no holes because the numerator and denominator cannot be factored. So we are done as far as case 1. So let's look at case 2. We have f of x is equal to x squared minus x minus 2 all over x minus 2. So case 2, go back to what was noted at the beginning. If there is a common factor at both numerator and denominator, there is a whole for the rational function. So first of all, let's find where will it be undefined at? Well, we would set our denominator equal to 0. Solve for x. Well, x is equal to 2, but what we're saying here, x cannot equal to 2. Therefore, our vertical asymptote, which will be a vertical line, will be at x equals to 2. So if we were to graph this, here is 2. We would create this vertical line. So to kind of give you a sense of what I'm talking about, because we will be graphing the vertical asymptote, the horizontal asymptote, we're going to put it all together in a few more videos that we need to cover at least horizontal asymptotes, and we'll keep going. So to find the whole, so what we will have to do, we will have to find the common factor. So we want to factor this numerator. So when we factor the numerator, what are factors of -2, that when we add those factors, it will give us the 1 here. So -1, in fact, we have x and x plus and a minus sign. So we have a +1 and we have a -2. So factors of 2, 1 and 2, that we have to apply a positive to the 1 and a negative to the 2, because when we add those together it would give us the -1 here. So what is the common factor that you see here? The common factor is x minus 2. Okay? So let's cross this out. Set that equal to 0, which we already did. We said x is 2. But when we reduce this rational expression, we have um, our solution is x plus 1. So what I want to do is find this ordered pair. Where would this whole be at? So to do that, what we're going to do to find the ordered pair, the whole, we're going to write it as an ordered pair. We have x, which is 2. We're going to go back to our solution here that we found, x plus 1, and substitute 2 in for x. So 2 plus 1 gives us 3. So if we were to graph x plus 1, I just want you to see this. So we know that when we graph this x plus 1, at 2, 3, there's going to be a hole. So we graph something like this, but at 2, 3, there's a hole. There's an interruption within that line there. So I wanted to at least show you what an example looks like, a case 2 looks like, that we talked about how to find the whole of a rational expression.